All right, so this is page 19, question 17. This one has a weird way in. So we follow our rules. CaO plus CO2 goes to CaCO3. It is a 1 is to 1 is to 1. The piece of information that I have is 8.50 grams of calcium. But calcium is not in this equation alone. It comes as a compound here attached to oxygen, or this over here. So what I can do is, our way in is through the calcium. So this is going to be the way in, and to do that we have to find the internal ratio for calcium oxide. So when I split calcium oxide apart, I'm going to get a calcium and an oxygen ion. So my ratio is 1 is to 1 is to 1. This is the piece of information that I have, 8.50 grams. So if I can turn that into moles, then whatever the answer to this is, I can transfer it to here, which means I can transfer it to here, and I can rewrite the moles for the rest of the equation. So 8.5 divided by the atomic mass of calcium is 40.08. When I do that piece of maths, I get 0.2121. So that means my calcium oxide is 0.2121 and my oxygen is 0.2121. Okay, so that has just been for this little portion of the equation. Because I now know what this, I can now transpose it up into here. So we know that this is 0.2121, this is 0.2121, and this must be 0.2121. So just from grams of an element in a compound, I'm able to find its moles in a compound, and now I can rewrite my ratio as moles for the rest of the equation. It says, using this amount of calcium oxide, so we are not finished yet, we're still on A. So I have 0.2121 moles of calcium oxide, and I need to turn that into a mass. So I will need calcium oxide to calculate the molar mass for calcium oxide. So it's 40.08. Oxygen is 16.00. This adds up to 56.08. So multiply my moles by my molar mass, 6.8, and when I do that I get 11.90 grams. So this is the answer for A. The next question then, using that amount of calcium oxide, calculate the maximum mass of calcium carbonate that can be found. So I'm over to here now. So this is my moles of calcium carbonate, and I need to figure out my molar mass. So again, I do my quick little bit. So carbon is 12.001 and it is O3, so there's 16.00 by 3. Add it all up and I get 100.09, which is the equivalent of 100.1 grams per mole. So I'm going to multiply this by 100.1 grams per mole. And when I do that, I'm going to get 21.23 grams. So this is my answer to B. And then the last question was, what volume measured at STP of carbon dioxide is needed for the reaction? So that is the 0.2121 multiplied by 22.4 litres. And when the calculator is done, it will come out at 4.751 litres. This is the answer for C. Okay, so a very weird way in, but you got to keep the faith and go through your steps and all will be well.